dear students, welcome back to our channel Diksha Karnataka. So as you all know that your midterm exams are approaching, and to help you with your preparation for midterm chemistry examination, today I am here with the complete revision of organic chemistry. Okay, so in today's video we'll be discussing two chapters, that is haloalkanes and haloarenes, and alcohols, phenols and ethers. Okay, so both of these chapters will be asked in your midterm examination. So we will be practicing a lot of questions, we'll be revising many reactions so that you can get very good marks in your midterm examination. Okay, so now without further delay, let's get started and let's see what is the question pattern, what are the different types of questions that can be asked here. Okay, so now as I tell you in my every class, please sit with a notebook and a pen so that you can note down all the important questions, you can write answers with me, you can practice these questions as well. Okay, so let's get started now. Okay, so two chapters are there in organic chemistry for midterm, haloalkanes and haloarenes, and then alcohols, phenols and ethers, right? Okay, now coming to the first chapter, that is haloalkanes and haloarenes. Now let us talk about the mark distribution. So in this chapter, that haloalkanes and haloarenes, total 9 marks will be asked. Okay, you will be getting questions from 9 marks. Now how is this 9 marks distributed? So 2 marks will be your 1 marker question, so that is your MCQs or fill in the blanks, and this will be of type remembering, and 1 will be of type HOTS. Okay, next, that is your little difficult question or higher order thinking question will be asked. Now coming to the short answer question, 2 marker, here you will get 1 question which carries 2 mark, and this will be of the type understanding. Okay, so will not be direct theoretical, but yes, some little bit tricky or little where you need to apply the knowledge, that type of question will be asked here. Now coming to the most important long answer question, 5 marker question, you will be 1 type, and that is very easy remembering. Okay, now I am telling you, this scoring 5 mark is very easy because the same question, or we know it is very predictable. Okay, this 5 marker, it can be either like SN1 mechanism or SN2 mechanism, or some reasoning questions that repeatedly the same questions have been asked over a period of time. So this question is highly predictable and easy to solve and easy to score as well. Okay, so please focus on these 5 marker questions, and this 2 mark question, like there are so many options, right? But in 5 marker question there are very limited options, so that will be definitely asked in the exam. So it is very easy for you to score this 5 marks. Okay, fine. Now let us go to the question. So we will be discussing first some MCQs. So I have picked up these MCQs from your blue model question paper that is released by the PUC. All the 3 model papers I have considered, I have taken the MCQs, and some questions I have taken from NCERT exemplar, because you have seen one type of question will be HOTS type, right? So exemplar questions are little bit not directly not direct answers, you need to think in that little bit. So that is why I have taken some questions from exemplar. Okay, so now let us solve this question. Okay, first question, statement based question. So enantiomers are non-superimposable mirror images on each other. This statement is correct, right? This definition of enantiomers is correct. Okay, a racemic mixture has 0 optical rotation. Yes, that is also correct, because we have equimolar mixture of levorotatory and dextrorotatory molecules. So that is why the net optical rotation value becomes 0. Okay, so both the statements are correct. So here both statement 1 and statement 2 is correct. So correct answer is option number A here. Okay, now let us see the second question here. 1,2-dichloroethane is an example of. So first let us see the structure. 1,2-dichloro, right? So you have CH2, and here 1 chlorine and here 1 chlorine. So you can see that this chlorine are present on the adjacent carbon, right? So these are called as vicinal carbons, right? So this is called an example of vicinal dihalides. Okay, next question. 4 haloalkane compounds represented by letter MNOP having the boiling points, these are respectively. Okay, first let us note down the values. Okay, so M, then we have N, O and P. So M value is how much? 24.2 degrees Celsius. Okay, then N is 38 degrees Celsius, then O we have 3.56, okay, and P is 101.6 degree. Okay, now what you can see here, that if we see MnOP, the lowest among the 4 compounds, N is most likely to be. Okay, so N, I have written correct values. M value is 24.2, N value 38, then we have O value and P value. Okay, so first let us see the options and try to arrange them. Okay, so now you see this highest value is 101.6 degree, right? Now then the boiling point increases with the increase in the mass, right? Now you see here the number of carbon is also more, 2 carbons are there, and here it is bromine group, iodine group. So definitely P is your C3H7 and I. Okay, now next one will be what? Here you see 2 carbon with bromine, so this one will be the next value. So 38 is the next value, so that is C2H5Br. Okay, now you see the lowest one will be 1 carbon, and out of chlorine and bromine is like heavier, so chlorine will be the least one. So O is CH3Cl, then definitely M will be CH3Br. So the N will be what? Then N will be C2H5Br, that is option number C. Okay, clear? Fine. Now coming to the next question, you have to match the following options. So here what happens, some like it is a question that has been taken from the all together from the organic chemistry, name reactions have been combined, but yes, we can recall some of the reactions and do them. Okay, so now if you see the first one, Gattermann-Koch reaction, this you will be studying in the aldehydes and ketones chapter, right? So this one is A is 3. Okay, so you can see all this one we can eliminate. Next, Stephan reduction will contains SnHCl2, so we can see B is 1. So here also B is 1, so we can eliminate this one. Now you know Rosenmond reaction is again Rosenmond is H2 palladium barium sulfate, so C is 4, so we have C4, and then D2 Itard reaction, right, this one. So that is why we can say that the correct answer is option number B here. Okay, next question. Toluene reacts with halogen in presence of iron chloride, giving ortho and para halogen compounds. This reaction is, okay, so this is what haloarenes undergo electrophilic substitution reaction. We have studied in detail that why haloarenes cannot undergo nucleophilic substitution reaction, right? There's a 3-4 points that is explained, and that is also a probable question in your exam. So that is why this answer has to be electrophilic substitution reaction. Okay, option number B. Next question. Which reagent will you use for the following reaction? So what is this reaction happening? You see chlorine is getting replaced or is replacing the hydrogen, right? So in the first one here there is replacement, in the second one on this carbon there is replacement. Now this is what we get, a mixture of product, or this is called halogenation of alkanes, or this is a method of preparation of haloalkanes, and for that we need chlorine in presence of UV light, right? That is option number A. Now what is the, if you remember this method, this is not a preferred method, right? This is not a preferred method. Why? You can see that we will get a mixture of products here. Okay, fine. Next question. Arrange the following compounds in the increasing order of their boiling points. So let us first discuss some points about boiling points. So boiling point will increase with the mass. If mass increases, boiling point will increase, directly proportional. And another point we have is boiling point is inversely proportional to branching. Okay, if there is more branching, then boiling point will decrease. If there is less branching, linear chain is there, then the boiling point will increase. Okay, now let us see these options. I hope these options are clearly visible. Okay, now you see 1, 2, 3, 4, 1, 2, 3, 4, all are having 4 carbons, right? So now that means mass will be same. We'll talk about in terms of branching, right? So what we got, the first thing here, mass is same. We cannot differentiate on the basis of mass. So the factor we need to consider is branching. right? So this is the linear chain B, so its boiling point will be maximum. So you can see only one option is there, so that is why option number C here. Okay, clear? Next you can see after B this one will come, because here less branching is there, here more branching is there. Okay, so least one will be C, then A, and then B. Okay. Next question, the position of Br in the compound is given, classified as. So let us see, draw this structure we'll expand it and draw it. CH3 CH double bond CH, then we have C, then we have Br, then you have CH3 and then CH3. Okay, now if you see, the bromine is present in the carbon which is attached to a double bond, right? The carbon containing the bromine is attached to the carbon which is having a double bond. So this position is called as allylic, or the correct answer will be option number A here. Next question, chlorobenzene is formed by the reaction of chlorine with benzene in the presence of AlCl3. Which of the following species acts the benzene ring in the reaction? So if you have seen, when you take chlorine, okay, in presence of AlCl3, okay, so what happens? This gives you Cl plus and AlCl4 minus, right? Now what is happening here? The benzene ring, okay, will attack on this chlorine and the reaction will happen. We have already seen that it is a electrophilic substitution reaction. So this reagent must be electron deficient. So by that one only you can eliminate these two options, right? This is electron deficient, but yes, this is a reagent which creates or which produces the electrophile. Okay, so correct answer has to be option number B here. Next question, okay, what is A in the following reaction? So if you can see, I'll draw the question once again. So the question is like this, you have this benzene ring, okay, and we have CH2 CH double bond CH2, okay, and you need to add HCl to this. Okay, this is very important question and many of you might do a mistake here. So now what do you think, if we follow Markovnikov's rule, what we will get the product? We will get like this, CH2 CCl, right? But before this I'll tell you that what was the carbocation formed here. This must be the carbocation that is formed, right? When you break the bond like this, following Markovnikov's rule, when you break the bond, then this carbocation will be forming, right? But can you see a more stable, this is a secondary carbocation, right? Can you think of a more stable carbocation that can form? So yes, this is a benzyl carbocation. So if a carbocation we get here, that will be very stable. So what happens, there is a hydrogen shift here and we get a compound like this, CH plus, okay, CH2 and then CH3. Now what will happen, the chlorine minus can attack on this one, okay. So the product here will be option number D, okay. Option number D will be the correct answer, where many of you might mark option C as the answer. Most of you will put this one as the answer, but you need to be very careful. Whenever there is a possibility of rearrangement to get a better cation, a more stable carbocation, the rearrangement will take place, okay. Next question, which of the following alkyl halides will undergo SN1 reaction most readily? So SN1 reaction, if you see the order, it is 3 degree, then 2 degree and then 1 degree, right? And in the SN1 reaction, the first step is formation of carbocation, right? First step is formation of carbocation, and in that case what happens, this RX bond breaks to give you R plus and X minus, right? So this bond has to break. If this bond is weak, then it can break easily, right? So if this X is iodine, then this bond is very weak because the size is more, carbon size is less, so there will be a poor overlapping of orbitals. So what is the order of bond breaking? Ri, then you have Rbr, then RCl and then Rf. Okay, so correct answer here will be option number D. Okay, next question. What is the correct IUPAC name for the given compound? Okay, so first of all, for IUPAC you need to number it. So now again here also many of you might think that this is the parent chain propane. Okay, but I'll tell you, if you see 1, 2 and here there are 2 carbons, right? 2 carbons. So I'll draw the structure once again for you. It is given like this: CH3 CH CH2Br, okay, and then CH2 CH3. Okay, now you might, if you do not expand it, many of you might think that this is the 3 carbon chain, right? Propane will be the parent name, but if you see, this one is the longest carbon chain here, right? So 1, 2, 3 and 4. On the second carbon we have methyl, so you can eliminate the options where the parent name is given as propane, right? We can eliminate this one. Here ethane, that is again wrong. Here 2 butane, that can be the answer, right? So now you see 2 methyl, okay, then we have 1 bromo. Now again the substituent should be named according to the alphabetical order. So 1 bromo will come, 2 methyl will not come here. So 1 bromo, 2 methyl butane. Option number C is the correct answer. Okay, next question. The reaction of toluene with chlorine in presence of iron and in the absence of light yields. Okay, so if you have, see, you have taken reaction of toluene, okay, with chlorine in presence of Fe dark. Okay, so this is your substitution in the benzene ring. So toluene or the CH3 group is a electron donating group, so it will be ortho and para directing, right? So we will get both B and C, so that is mixture of 2 and 3. Okay, option number D here. Okay, next, molecules whose mirror images is non-superimposable over them are known as chiral. Which of the following molecules is chiral in nature? So here you should know what is the condition for chirality. See, every time if a molecule is given, you won't draw its mirror image and check whether it is superimposable or not, right? Every time it is a very tedious process. So to know that whether a compound is optically active or not, that it should be chiral or not, then we have a condition here that it should have, see, right here, condition for chirality, okay, that there should be a presence of asymmetric carbon. Now what is asymmetric carbon? Asymmetric carbon is something where 4 different groups are attached. 4 different groups are attached to the same carbon, right? That is called asymmetric carbon. Now let us draw the structures of all these options. 2-bromo-butane. So if you see, it is like this: 2-bromo-butane. Right? Now if you see this structure, I have this carbon, okay, one side methyl group, one side hydrogen, one side ethyl group and one side bromine group, right? All the 4 groups are different, right? So this can be optically active. So our correct answer will be option number A. Now if you check 1-bromo-butane, 1-bromo-butane, if I show you, the structure is like this: CH3 CH2 CH2 CH2Br. Here if you consider this carbon, this side there is 1 group, no doubt. Here there is bromine, but on this carbon there are 2 hydrogens, same hydrogen, right? So that is why this is optically inactive. Similarly, you can check for 2-bromo-propane, it will be same: 2-bromo-propane 2OL, 2-bromo-propane 2OL, okay? So that is this one, 2-bromo-propane 2OL. So here you can find different groups, but these 2 groups are again same, okay? So that is why correct answer will be option number D here. Next question. Now which of the following compounds will give racemic mixture on nucleophilic substitution by OH minus? Now this question is little indirect, so you need racemic mixture, right? So if you know, we get racemic mixture in SN1 mechanism. And what is the order of SN1 mechanism? 3 degree, 2 degree and 1 degree, right? So now if you see this first one, like how to find out, this carbon, the first option is like this, you have CH3, C, C2H5, H and Br, right? Now this carbon which contains the halogen is attached to 2 more carbons, right? So that means this is a secondary carbon. Now if you see the option number B, okay, how is this one present? It is like this, CH3, CBr, okay, CH3 and then C2H5, right? Here the carbon which contains the halogen, is attached to 3 other carbons, right? So that is why this is a tertiary group, and the last one you can see this is primary. So the correct answer will be option number A. So we need tertiary carbon, right? Because tertiary will give you racemic mixture. Option number B. Clear? So now we have discussed enough MCQs, that is what can be asked in your so generally you need to focus on SN1 and SN2 a lot of time, and the physical properties, arrangement of boiling point and arrangement of the order of boiling point based on mass, based on branching. Some from these type of questions you can easily expect MCQs, okay? So now we will move forward towards the 2-marker question. So there will be 1 2-marker question from this chapter. So we will practice 5 to 6 most probable 2-marker question. So there are a lot of name reactions that you can prepare from this chapter. Explain Schwartz reaction with an example. So here I'll tell you one format. Whenever name reaction is asked, okay, whenever name reaction is asked, first you need to write definition, okay, second you need to write example, okay. In example you should keep one thing in mind, sometimes it is already given that what example you need to give. Like for example, here it will be given explain Schwartz reaction with bromomethane or bromopropane, then you have to take that particular compound which is given in the question to take as an example, okay. So first should be definition and next should be example. Now here about for definition I'll tell you, need not remember exactly like in the NCERT book, need not remember line by line, okay. You can modify the definitions here, no problem, okay. So like for example we'll see Schwartz reaction is what? Reaction of Schwartz reaction is for your you can see for the preparation of fluoroalkanes, right? So now you need not write exactly this definition, you can simply write when alkyl halides, okay, in presence in, you can write where it can be chlorides or bromides, reacts in presence of metal fluorides to give you fluoroalkanes, that is called as Schwartz reaction. Getting once what I am saying? See, alkyl fluorides are synthesized and all by heating, nothing is required. Alkyl fluorides can be produced or can be synthesized by the reaction of alkyl chloride or bromide in presence of a metallic fluoride such as AgF, HgF2, COF2 or SbF3. This 4 also you need not write, you can write any 1 or 2, the first 2 you can remember and you can write, right? So that will give you 1 mark. Clear? Now you have to write one example. CH3Br plus AgF gives you, here just you need to exchange CH3F plus AgBr, right? The product, the reaction carries 1 mark. Clear? Understood how you need to write the definition? Definition has to be written in terms of the, you can just see this reaction and write down your definition in your own words, okay? You need not remember the exact line by line how it is written in your book. Clear? Okay. Next, going to the second question. Chlorobenzene cannot be prepared by reacting with phenol with SOCl2. Give reasons. So here there can be another type of question also. The answer will be same, in a different way it can be framed. That is why, that is why haloarenes do not show nucleophilic substitution reaction. Okay, whether this question or this question, the answer will be same. Okay, why haloarenes do not form nucleophilic substitution reaction. Now let us see this question. Chlorobenzene, okay, the question is asking if you react phenol, okay, with SOCl2, right? If you remember, if you react ROH plus SOCl2, we used to get RCl, right? So similarly, if this one is there, then this reaction will not give you chlorobenzene. Now what is the reason for that? Okay, so here you should remember why this is not happening. The first thing that can, the first reason is the hybrid, the presence of resonance here. Okay, the first effect is resonance effect. Okay, so you can write down here. Okay, one second. Okay, the first point is resonance effect. You can write due to the resonance, here CCl not this COH bond. Okay, due to resonance CO bond. Okay, due to resonance CO bond has a partial double bond character. How that partial double bond character? Due to resonance we get a partial double bond character. So it is very difficult to break this bond, right? So due to resonance the CO bond has a partial double bond character, as a result of which it is difficult to break the CO bond. Okay, next one, the hybridization of CO bond. Hybridization of CO bond. Okay, or you can just write down hybridization of carbon. Okay, so in haloarenes, the carbon in in haloarenes, right? So we need to write in phenols here. So this is, I'll change this answer. Okay, so write down in phenols. In phenols, okay, the carbon in CO bond is sp2 hybridized. Okay, sp2 hybridized, and hence cannot be broken easily. Clear? In phenols, the CO bond, because we are talking in terms of phenols, right? So directly we cannot take direct copy paste, we cannot do, we need to modify the answer based on the example given, right? The first thing here is this bond cannot break because of resonance. The second point is because this carbon is sp2 carbon, so this bond is very strong, and that is why also it is difficult to break this bond. Clear both the points? Next question. Fittig reaction, again what is Fittig reaction you need to write, then the definition and one example. So in Fittig reaction what happens? The haloarenes react. So I'll tell you the definition in simple words. Haloarenes react in presence of sodium and dry ether to give you diphenyl. Okay, that is the statement. So you can write haloarenes or aryl halides when treated with sodium in dry ether give compounds when two aryl groups are joined together. Okay, you can write down these two aryl compounds as in one word, that is to give diphenyl. Okay, it is called Fittig reaction. Now you can just write down an example. So here when you are giving example, it is better to take the compound, like you can take chlorobenzene. Okay, so 2 chlorobenzene plus 2 Na in presence of dry ether will give you diphenyl and 2 NaCl. Okay, so that will be the answer for this question. Clear? So till now we have discussed Schwarz reaction and Fittig reaction. Next question number 4, Wood's Fittig reaction with an example. So same thing you need to write here. The reaction of Wood's Fittig reaction is what? We have Rx plus ARX, right? When, so you can write down when haloalkanes and haloarenes react in presence of sodium diethyl to give you the compound, that is called as Wood's Fittig reaction. Okay, here you can write one example. When a mixture of alkyl halide and aryl halide gives alkyl arene, so product name is alkyl arene, when treated with sodium in dry ether is called as Wood's Fittig reaction. Okay, so here you can write down the example. You have this one here. When you write the example, you can give the like crop, as I told you can take chlorobenzene, here you can take chloroalkanes. Okay, and here you can write down haloarene. Okay, and here you can write haloalkane. So just to denote that these two are reacting. Okay, to give you, this is what? Alkyl arene. Alkyl arene. Okay, so product you can write down whichever X you have taken, you can write down in this way. Clear? I hope this is visible. Please check is it visible or not. Okay, you can write down the reactions like this. Okay, now we'll go to the next question. Write the steps involved in SN1 mechanism for the conversion of tert butyl chloride to tert butyl alcohol. So I am telling here, in acid, suppose the question is given, write an example for showing the mechanism of SN1 reaction. So in that case you can write whichever term you want, whichever you take, that is fine. But when it is given tert butyl alcohol and tert butyl chloride, you need to take these molecules only as an example. Okay. So let us write down this one. Step number 1 is what? Formation of carbocation. Okay, this is step number 1, formation of carbocation, and we will take the molecule as it is given, which is given tert butyl chloride, right? So we have CH3, CH3 and then Cl. Okay, now here what will happen? This bond will break and we will get, so you can write this is a slow step. So we will get CH3 and then 1 plus, right? So this is the first step where there is formation of carbocation. Now what is the second step? Attack of nucleophile, right? Attack of nucleophile. Now what is the nucleophile here? You see it is given alcohol. We need to convert it into alcohol. So what should be the nucleophile here? OH minus should attack, right? Now what we can do? We can write like this. Okay, I'll write it here. CH3, and then here it is a plus, then here you have OH minus, and then it will attack on this one, and we get CH3, CCH3, OH. Now since this is not a chiral molecule, you can show it like this. If it would have been a chiral molecule, then you have to show both the enantiomers. Okay. Now here what thing you can write out is the first step. Okay. So 2 methods, 2 steps, 2 marks you will easily get. Okay. Next step. Okay. Question number 6, write the steps involved in the SN2 mechanism. Okay, now we'll do SN2 mechanism for the conversion of chloromethane to methanol. Okay, so we have chloromethane. Okay, so chloromethane. I'll write it so that we can chloromethane. CH3Cl. Okay. So it is a one-step reaction, right? Chloromethane and then conversion to methanol. Then again OH minus will be the nucleophile here. So OH minus cannot attack from this side because it is hindered. So OH minus has to attack from the back side. You need to show this. Okay, this arrow mark has to be shown in the backward direction. Now what we will get? A transition state is formed here. So CH, HH, and what happens? One second. Now what happens? This Cl bond is going to form and this OH bond is, Cl bond is going to break and this OH C bond is going to form, right? So that you need to show with dotted lines. Okay, this has to be shown in dotted lines, and here you need to write that this is a transition state. Okay, after this what happens? This bond breaks and we get here the compound that we need. So we will get the product. So aroma continues. Try to write the whole reaction in one line. Okay, so now we will get OH will be attached on the opposite side, and we have H here, and H here. Okay, so that will be the product. Again, because this is a not a chiral molecule, so there we cannot find inversion, but yeah, we can show in the mechanism. Okay, next, what are Grignard reagents? Write its general formula. Okay, so what is Grignard reagent? First definition. So you can write organometallic compounds, having direct bond between carbon and magnesium are called as Grignard reagent. Okay, please write the full word here, Okay, now example, general formula is R mgx. Clear? This carries 1 mark, this carries 1 mark. Okay. Next, what are freons? Name the poisonous gas involved when chlorine is oxidized by air. So here you see you only need to write the name of the gas, so no need to write the how the gas is produced. And what are freons? So chloromethane or methane, when the hydrogens are replaced by fluorines or chlorines, we call it chloromethane, or we call it freons, right? So you can see the example here. The chlorofluorocarbon compounds of methane and ethane are collectively known as freons. Okay, here this definition is already very simple, just you can remove this word collectively. So the chlorofluorocarbon compounds of methane and ethane are known as freons. Now what is the name of this gas? So this is part 1 and this is part 2, phosgene, formula COCl2. Okay, so this carries 1 mark and this carries 1 mark. Okay, by just writing the name of the gas you will be getting 1 mark here. Next question, explain Finkelstein reaction with an example. So if you remember, Finkelstein reaction is for the production of iodoalkanes, right? So you can write down, when chloro or bromoalkanes are reacted with sodium iodide in presence of dry acetone, it gives iodoalkanes. This reaction is called as Finkelstein reaction. So just you can see, this I have taken from the book, so you need not write this one. Alkyl halides, alkyl iodides can be prepared by the reaction of alkyl chlorides or bromides with NaI in dry acetone. This reaction is known as Finkelstein reaction. Now we need to give an example, so I will give like this: CH3Cl, presence of NaI, dry acetone. Okay, you can write plus NaI also, that is also fine, and that will give you CH3I. Here I should mention that this is chloromethane, okay, and this is iodomethane. Clear? Okay. Next question. Explain Friedel-Crafts reaction by taking chlorobenzene as an example. So you cannot consider any other molecule, you need to consider only chlorobenzene. Okay, now when it is asked Friedel-Crafts reaction, it includes both Friedel-Crafts acylation as well as Friedel-Crafts alkylation. So you need to write for both. Okay, so here you can see the definition we can write in one line: the alkylation or acylation of haloarenes with alkyl chloride or acyl chloride in presence of AlCl3 is known as Friedel-Crafts alkylation, right? Friedel-Crafts reaction, sorry. Okay, the alkylation or acylation of haloarenes in presence of alkyl chloride or acyl chloride and AlCl3 is known as Friedel-Crafts reaction. Now just you can put the reaction like this. So just put chlorobenzene here, okay, and then you can use like CH3Cl, AlCl3, okay, and then you can put here the products, any one product is done, that is also fine, CH3, and here you can give CH3COCl, AlCl3, and here we will get acylated product, right? So that is Cl and COCH3. Okay, so this is what? This is acylation, okay, and this is alkylation. Clear? Just you can write down the example like this. Okay, now next question, define stereocenters. Explain why in case of optically active alkyl halides SN1 reactions racemic mixture is formed. Okay, so first point, what is stereocenter? Let us define it in one line. So stereocenter is that carbon where 4 different groups are attached, right? So you can write the carbon which has 4 different groups is called as a stereocenter. Okay, next point, explain why in case of optically active alkyl halides SN1 reaction racemic mixture is formed. So here you can write, in case of SN1 reaction, carbocation is formed, right? Right, first step is the formation of carbocation. Now what happens? The nucleophile can attack both from the like above and from the below. It can attack from the front side as well as from the back side, because this carbocation is a planar molecule, right? You can write, in case of SN1 reaction, carbocation is formed as an intermediate, okay, as an intermediate which is planar. The nucleophile, okay, can attack from both sides and we get an equimolar mixture of dextro and levorotatory products. Okay, so that is why the racemic mixture, so that is why a racemic mixture is formed. Okay, next, so now we are done with 2 marker questions, almost 10 questions we have practiced. So now we will go for 5 marker question, okay, from where this part is very scoring topic, very easily you can score marks here. So let us see these questions. Okay, first question, there is an alkene, you are adding HBr, right? Which rule is to be followed here? Markovnikov's rule is to be followed. So we will get this compound is like this, CH2, then we have next one double bond here, then we have CH and then CH3, right? So now if you see here, this carbon is having less number of hydrogen, so here the bromine will be attached, so the product here will be CH2, CHBr, CH3, okay, 2-bromopropane. Next, dash plus we are getting dash in presence of sodium diether, we are getting a ethane here. So if you remember, in ethane we get the double the number of carbon atoms, right? So this must be, if here there is 4 carbons, then here must be, it should be 2 carbons. So we have to take what? We have to take ethyl chloride. Okay, 2 times of ethyl chloride will give you butane. Next, chlorobenzene with NaOH at very high temperatures. So we know nucleophilic substitution are generally not possible, but at very high temperature and very high pressure it can take place, and here we will be getting the product of phenol. Okay. Next question, explain Saidzev rule with an example. Saidzev rule with an example. So let me erase this one. What is Saidzev rule? So Saidzev rule says that during dehalogenation, dehydrohalogenation, the most stable or most substituted alkene is formed as the major product, right? So what is Saidzev rule? According to Saidzev rule, during dehydrohalogenation means you are removing one halogen and one hydrogen, more stable alkene is formed. More stable alkene is formed. Okay. Now if you want to see the example for this one, we can have like you can take example, right? So we'll take CH3, CHCl, okay, and then CH2, CH3. Okay, so let me erase this one here. 1 second. We'll draw that product on that side. Okay, so this one will give you phenol. Okay, now what happens here? We have, if you, for dehydrohalogenation, what is the reagent required? We required alcoholic KOH, right? So now what happens, you can see that we have 2 options. 1 second, we'll show the options also. Okay, so it can either happen that this HCl will go, or if we have one H here, this H can also go. But if you see this one is going, then we are getting more substituted alkene, right? So the major product here will be CH3, CH double bond CH, CH3. Okay, so this has to be the major product. So this example you can give, and then you need to write the definition, 2 marks. So this total 3 carries 3 mark and this one carries 2 mark. Okay. So generally the 5 marker questions are divided in this way, 3 plus 2. Okay. Next, write any 3 differences between SN1 and SN2. I think this is very easy question. Everyone should be able to write this one, but let us discuss. First one, okay, SN1 and SN2. First point you can write, this occurs in 2 steps, right? And here it is only 1 step, right? Second, here you can write carbocation intermediate is formed, no intermediate is formed. Third, you can write the order is 3 degree, 2 degree and 1 degree, and here it is 1 degree, 2 degree and then 3 degree. Next, you can write down this is a first order reaction, and this is a first order, and this is a second order reaction. Okay, so these are the some points you just need to write any 3 points from here. Next, identify A and B in the following reaction. So this is again in the preparation of haloarenes part. So NaNO2 and HCl, if you remember, this converts your NH2 to benzene diazonium chloride. So what is A? A is benzene diazonium chloride. Okay. Next, you have to use either Gattermann reaction or Sandmeyer reaction to get the product. So you can write B can be either Cu2Br2HBr or CuHBr. Okay. So if you take this one, Sandmeyer reaction, this is Gattermann reaction. Okay. Fine. Next question. Write the mechanism involved in the conversion of 2-bromo-2-methyl propane to 2-methyl propane 2-OL. So what is this one? Let us see. 2-bromo-2-methyl propane. So you have, one second. Okay. 2-bromo-2-methyl propane. Okay. 2-bromo-2-methyl propane. Okay, the question is very similar but asked in a different way. CH3, COH, CH3 and then CH3. Right? 2-methyl propane 2-OL. Now this is what? This is a 3 degree one, right? If it is 3 degree, then what will happen? SN1 mechanism will be followed. So directly it has not asked you to write the mechanism of SN1, rather it has asked you to find out which mechanism and then write down the mechanism. Like what you need to identify whether it is SN1 or SN2, then you need to write down the correct steps. So just now we did it. Step number 1 will be what? I will not write in detail now. Step number 1 will be carbocation formation, and we will get like this. I am writing like this. This bromine will go out and we will get CH3 whole 3 C plus, and step number 2 will be the attack of the OH minus. So you can write like this, C plus OH minus will give you CH3 whole 3 COH. Okay, but you need to write correctly with drawing the structures. Okay. Next, what are enantiomers? So enantiomers are non-superimposable mirror images, right? Non-superimposable mirror images. Okay. Next, so this carries your 3 marks, right? So you need to write this first line also. What is it? That is, first line here will be carbocation formation or formation of carbocation. Second step will be attack of nucleophile. Okay, fine. Now we discussed already what is enantiomers. Name one physical property which differs in enantiomers. So you might have studied that all enantiomers, okay, they have similar physical properties. Their boiling point, melting point, their density, mass, everything is same, but their chemical properties are different. But there is one physical property which is similar, which is different in the 2 enantiomers, and that is what? Rotation of plane polarized light. Okay, so one of the enantiomer will rotate it in clockwise direction, another will rotate it in anti-clockwise direction, right? Okay, so next coming to question number, oh, one second, yeah, question number 4. Write the equations for the step involved in the SN1 mechanism of hydrolysis of 2-bromo-2-methyl propane. Okay, the same thing, the same question you can see, refer answer 3. Okay, next, name the product formed for the reaction of isopropyl iodide on alcoholic KOH. Okay, so first one B I'll discuss here. So first of all, you should know the name. What is this isopropyl iodide? The common name is given, right? So isopropyl iodide is 2-iodopropane. Now when you treat it with alcoholic KOH, so what will happen? Dehydrohallucination will take place and we will get a propene as a product. So CH3 CH double bond CH2. Okay, that is your first answer. Next, what is the condition to be satisfied for a compound to be okay, so this is your 2 mark. This is name the product. Okay, this is 1 mark and this is 1 mark and this is 1 mark. Okay, so what is the condition to be satisfied for a compound to be chiral? So for a compound to be chiral, what condition should be satisfied? 4 different groups should be attached to the carbon. Okay, next, what is racemic mixture? Equimolar mixture of 2 enantiomers, okay, such that the optical rotation is 0. Okay, clear? So we'll get 2 plus 2 plus 1, 5 marks. Okay, fine. Now equimolar mixture of dextrorotatory or levorotatory isomers is called racemic mixture, or you can write equimolar mixture of 2 enantiomers. Okay, now next question, this is an ABCD type of question. In your board exam model test paper, such questions are not there, but yes, previously such type of questions are being asked. But this question, if you practice, you can practice a lot of reactions, so that's why I have put this type of a question. Okay, it may be asked in the exam also, so we'll practice this type of question, word problems. Okay, now first of all, it's given primary alkyl halide C4H9Br. So when you read this type of questions, once you read one statement, write down the data that is given. So we have what? C4H9Br is there, C4H9Br, this compound is named as A. And what is the speciality of this one? This is a primary alkyl halide. Okay, reacted with alcoholic KOH to give you B. So we have here alcoholic KOH to give you B. Now if you remember, primary alkyl halides with alcoholic KOH will take place what? Dehydrohallucination. So this B has to be an alkene. Okay, next, compound B is reacted with HBr to give you C. Okay, is reacted with HBr to give you C. Okay, next, which is an isomer of A. So C is what? It is a isomer of A. Okay, next, when A is reacted with sodium metal, it gives you compound C8H18. When A is reacted with sodium metal, it gives you C8H18. Okay, so that must be, this is your Wood's reaction, right? So this is Wood's reaction. Next, which is different from the compound formed when N-butyl bromide is reacted with sodium. So it is telling that this compound which is formed C8H18, that is D, is not the one which you will get if you react N-butyl bromide with sodium ether. Okay, then give the structural formula of A and write the reactions involved for all the reactions. Okay, let us do this question now. So first of all, we have C4H9Br and it is a primary alkyl halide. So now for C4H9Br, what are the possible primary alkyl halides we have? Okay, so we can do like this: CH3, CH2, 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 Br. That is one possible primary halide. Another we can have is CH3, CH, CH3, CH2, Br. Right, these two are possible. Now they have already told you that the compound of A, okay, D, see this, the last point, fourth point, D is not that compound which is formed when N-butyl chloride will react. So that means N-butyl chloride will not react. So that means this cannot be there. So this has to be your A. Okay. So A structure found out. Now it is reacting with alcoholic KOH. So what will happen? There will be dehydrohalogenation and we will get this compound, right? That is an alkane is formed here. Now after that what is there? You need to write the reaction separately, okay? After that we are adding HBr. So there will be Markovnikov's addition. Br will be attached on this one. I'll get CH3, CCH3, Br and then CH3. And they have told that about, this is B, right? About C, C is an isomer of A. So is it an isomer of A? Yes, you can see here bromine is present in the first carbon and here bromine is present in the second carbon, right? And the structure is also different. Yeah, so this is a functional, this is a different isomer, chain isomers you can say. But the compound A and C are related in this way. Next you have done what? Next we have done, okay, that's all right, A, B, C, D. Okay, now if you react A with sodium ether, right? So we are reacting A, which, where is A? This is A, right? So if you react it with sodium and ether, so what will happen? This same compound will form, like you have to just make a replica of this one. This is CH3, C, CH3, we have CH2Br, right? Now again this part will be copied on this side. We'll get C, CH3, CH3, CH. Okay, so this is your compound number D. So you need to write all these reactions separately. 4 reactions, 4 mark. A, if you write the structure correctly, 5 marks. Okay, fine. So we are done now with haloalkanes and haloarenes. Okay, now we will move towards the next chapter, that is alcohols, phenols and ethers. Okay, now first let us discuss the mark distribution for alcohols, phenols and ethers. Okay, so in this chapter total you are getting 10 marks. Okay, 10 mark questions will be asked from this chapter. In that there will be 3 MCQs. Okay, you will be getting 3 MCQs, 3 1 marker question. It can be MCQ or it can be asked in the fill in the blanks. 3 questions will get from here. Then there will be 1 2 marker question. Okay, 1 2 marker question and as usual organic 1 5 marker question. So you can see 5 6 7 plus 3 10. Okay, so the same pattern was there for haloalkanes and haloarenes also. It was 2 here, right? So 5 6 7 8 9 and here it is 5 6 7 8 9 10. Okay, so clear. So now we'll go, now I haven't put here whether it is application type, remember type based, because there were 3 blueprints, right, as it was released by the PUC, and they have not, like somewhere they have made it like remember and understand. It has been changed in different papers, right? So we will include all types of questions and we will practice all type of questions, whatever question the examiner may give, but we will tackle it, we'll crack it, right? So that is why I have not mentioned any type. We will be doing all types of questions in this particular category. Okay, so are you ready? I know the video is becoming little long, you might have become tired, but remember, just if you watch, you will revise. This is a revision part. You will definitely be able to score good in your board exams, right? In your midterm examination, sorry. So we'll start now with the first question. The chemicals, so this question was there in your blueprint. The chemicals used to convert commercial alcohol into denatured alcohol. So if you remember, what is denatured alcohol? Yeah, sometimes to make the commercial alcohol unfit for drinking. Okay, if you don't, like if you want to make it spoiled, you can say in one way, you want to make it unfit for drinking, then what has to be added? So for that we add copper sulfate with pyridine. Okay, so correct answer will be option number C here. Clear? Next question, let us see. Okay, again statement based question. Now tertiary alcohol heated with copper at 573 Kelvin yields 2-methyl propene. So if you remember, tertiary alcohol, okay, when you heat it with copper at 573 Kelvin, there will be a double bond formed here, right? So what will happen? Dehydration takes place and we get this question. We get this product. Okay, so what will be the name? 1, 2, 3. So 2-methyl propene, that is what is given, 2-methyl propene. So this statement is correct. Now tertiary alcohols undergo dehydration when held with copper, when heated with copper 573. Yeah, this is a dehydration reaction. So both 1 and 2 are correct. Option number A. Clear? Next, the products formed when phenol is treated with excess of bromine water is or are. So if you remember phenol, okay, if phenol is a highly reacting group, if you react it with bromine water, we get OH and all these positions are replaced with bromine, right? Now if I want to get ortho and para group, then what should be the reagent? Please comment down in the answer section. Okay, what should be the reagent to get only ortho or para product? Okay, so if you have seen, so it will be 2,4,6 tribromophenol. So that is only 4. Option number B here. Next, which one of the following observation is shown by 2-methyl propane 2-OL? 2-methyl propane 2-OL with Lucas reagent. So Lucas reagent, what is Lucas reagent? If you remember, Lucas reagent is anhydrous ZnCl2 in presence of AlCl3. Now what is the use of this reagent? It is used to distinguish between primary, secondary and tertiary alcohols, right? Now how does it distinguish? Tertiary alcohols reacts immediately. Okay, and what is the observation we find? Turbidity. Turbidity is formed immediately. Secondary, turbidity is formed after 5 minutes. Okay, and in primary what happens? No reaction, right? So this is what is Lucas reagent and how does it differentiate between 3 degree, 2 degree and 1 degree. So turbidity will be observed after 5 minutes. This is for secondary alcohol. Now let us see what is our question. 2-methyl propane 2-OL. So if you draw this structure, 2-methyl, okay, propane 2-OL. So this is a tertiary, right? 3 degree alcohol group. No turbidity will be observed, that is if it is a primary. So this also is not the answer, this also not be answered. Turbidity will be observed immediately. Yes, for 3 degree turbidity will be observed immediately. So correct answer will be option number C here. Okay, next, monochlorination of toluene in sunlight followed by hydrolysis with aqueous NaOH yields. So monochlorination of toluene. So first it is given toluene. Okay, monochlorination means only one time chlorination has happened with sunlight, right? So here this reagent adds chlorine in the alkyl part, right? It doesn't add chlorine to the benzene ring. So we'll get CH2Cl. Now if you react it with aqueous NaOH, so aqueous NaOH, what will happen? Rx gets converted to ROH, right? Rx in presence of aqueous NaOH gives ROH. So what we will get here? We will get CH2OH, right? So this is called as benzoyl alcohol. Okay, option number C. Okay. Next, what is the correct order of reactivity of alcohols in the following reaction? So here if you see ZnCl2 ROH, so here the reactivity order is 3 degree, 2 degree and 1 degree, right? So correct answer will be option number C. Next, CH3CH2OH can be converted into CH3CHO by. So now what is this one? CH3CH2OH will be converted to CH3. One second. Okay. So the question is CH3CH2 OH will be converted to CH3CHO. Okay. Now by what are the reagents required here? So if you remember, we need mild oxidizing agents here. Okay, if you use strong oxidizing agent, what will happen? In case of strong oxidizing agents, we will get acids, right? So we need mild oxidizing agent. Treatment, catalytic hydrogenation. Okay, treatment with LiLH4, that is a reducing agent. We need oxidizing agent. This cannot be answered. Treatment with pyridium chlorochromate. Yes, this is a mild oxidizing agent, PCC. Okay, so correct answer has to be option number C. Treatment with KMnO4 will convert it into acid. Okay, now reaction with hydrogen will not be giving you CHO. So correct answer will be option number C. Okay, clear? Next question. IUPAC name of the given compound. So for IUPAC name, first you need to number it. Okay, so we need to number it such a way that OH will get you least priority. 1, 2, 3, 4, 5 and 6. Okay, so now let me draw this compound again. It might not be visible clearly. CH3, CHCl, CH2, CH2, CHOH, CH3, right? So 1, 2, 3, 4, 5 and 6. So second carbon there is this OH group. So name must be ending with OL. So we can eliminate these options. Now if you see 5-chlorohexane 2-OL, right? Correct answer is option number C here. This naming, this is wrong because the counting has been done on the opposite side. Okay. So now let us see the next question here. You have to find out the correct increasing order of reactivity of following compounds with HBr or HCl. Now see what happens. How does HBr or HCl reacts with alcohol? So if you have an alcohol, okay, first what happens, it reacts with H plus and we get RO plus H2. Okay. In the next step what happens? So there is loss of water and we get R plus. So what I can say is there is a formation of carbocation. Okay, next step what happens, this R plus is there and then this Cl minus or Br minus can attack to give you RCl. Okay, so this is the mechanism. The point of telling the mechanism here is we need to understand this reaction proceeds by the formation of carbocation. So what we need to check? We need to check the stability of the carbocation. In whichever option carbocation is more stable, that will react faster. Okay, so now if you see the first one, we have CH2OH, right? First compound is CH2OH. So first this will get protonated and then it will leave. So what will be the carbocation that will be formed here? CH2 plus, right? Option A. And here if you see next one we have, here we will be getting the same thing with NO2 group here. And for the next one we will get CH2 plus with Cl. Now see, NO2 is a very good electron withdrawing group. It withdraws by minus R effect. Chlorine is what? It is an inductive group. Its inductive effect is more powerful. So it is also electron withdrawing group, but it withdraws by minus I effect. Now electron withdrawing group means what? They will withdraw electrons from here, means this plus charge will become more. Okay, so that means it is destabilizing the carbocation. Okay, so more destabilize. So and you know, if plus R and minus R and minus I, minus R is the dominant effect. So here the carbocation will be more destable, so this will be least reactive. So we need B at the least. So we can eliminate option A and D. Next, if you see, this is next will be your C. So B, then C, then A. So correct answer has to be option number C here. Okay. Next 9, mark the correct order of acidic strength of the following compounds. Okay, so acidic strength is dependent by the groups attached. So you should remember, electron withdrawing group increases the acidity, electron donating group decreases the acidity. Okay, clear? Now here you see there are electron withdrawing groups, NO2 groups are there, right? So definitely this one will be, these two will be more acidic. B and D will be more acidic. Now here you see there is only one option where B and D is there, and out of B in the para position it is more effective. So option number B has to be the correct answer. Now after B and D there should be A. right? Because here what is OCH3? This is electron donating group, but this is electron withdrawing group. One second, see, this is electron withdrawing group and this is electron donating group, right? Now electron donating group will decrease the acidity, that means your C and E, this is also electron donating. C and E should be at the end, okay, here, and A, which is having no other substituent, that will come at the middle. So option number B will be the correct answer here, okay. Next, arrange the following compounds in the increasing order of their boiling point. So boiling point here also you should remember, boiling point is proportional to mass, okay, and inversely proportional to branching. So we have propane 1OL, butane 1OL and butane 2OL and pentane 1OL. Okay, so you have to find in the increasing order. Okay, so the options are given according okay, so fine, let us find first, it should be increasing order, the least one. So propane 1OL is the having least number of carbon, so that has to be at the first. So we can eliminate option C and D, propane 1OL, propane 1OL, and the highest one definitely should be pentane 1OL because it has 5 carbons, right? Now if you see, here there is no branching, but here there is branching. So a butane 2OL structure, if you see, this is butane 2OL, right? You have, this is butane 2OL and butane 1OL is like this. Let me draw. Okay, so butane 1OL has no branching, it will have more boiling point than butane 2OL. So after that butane 2OL, then butane 1OL, then pentane 1OL. That is option number A here. Okay. So we are done with the 1 marker questions. So 2 MCQs will be asked. You need to prepare everything for MCQs. Now we will heading towards the 2 marker question. Most expected questions that can be asked from 2 marks. Okay. So write the reactions involved in the preparation of phenol from cumene. Okay, so this is a direct question. Cumene preparation, why this question is asked, you should remember that this is the commercial method, right? Commercial method for the preparation of phenols. So now let us see the reaction. I have taken this from NCERT book. So cumene is nothing but isopropyl benzene treated with oxygen. What happens here? This carbon gets oxidized and OOH is added. Then just hydrolyze it, H plus and H2O. So you just remember this OH attaches here and this gets converted to acetone. Okay, so this is the method of preparation of phenol from cumene. Okay. Next question, explain the preparation of methoxyethane by Williamson ether synthesis. Give the reactions. Okay. So if you remember, in case of Williamson ether synthesis, what are the reactants? We have Rx plus R-ONA. Okay, and this Rx, this reaction happens in SN2 mechanism, and this Rx must be primary. Okay, now what we want to prepare? Methoxyethane, that is. Okay, now the question arises whether we should take this one as Rx or we need to take this one as Rx. So whichever is less hindered, okay, whichever is less hindered should be Rx. This Rx property should be less hindered. Okay, so that means I need to take CH3X and CH3O minus Na. Okay, so first you need to explain, means you need to write in words, then you just need to write the reaction. So here I can write down methyl chloride, okay, reacts with sodium ethoxide, in presence of dry ether to give methoxyethane. Clear? This is the reaction, first one. Next you have to write the equation. So you have CH3Cl plus CH2CH3O minus Na plus. Clear? So now if this one will react, this one will attack on this one, this bond will go out, so I'll get CH3O, CH2, CH3. Okay, so this will be the method of preparation. 1 mark, 1 mark. You will get 2 mark if you write the in words, then you can explain in terms of reactions. Okay, next. Okay, next one. Complete the following reaction by name. Complete the following reaction and name the reaction. Okay, so if you have okay, let me clear this one because it is already I've given a answer. Okay, so now we'll go to the next question. Complete the reaction. So if you see CHCl3 NaOH, this is your Reimer-Tiemann reaction, and the product formed will be OH. Okay, and we will get CHO here, right? And what is the name of this reaction? As I told you, it is Reimer-Tiemann reaction. Okay, so you will write the product 1 mark. So if you write the product correctly 1 mark, name of the reaction 1 mark, you will get 2 marks here. Okay, next, what is esterification reaction? Give an example. Okay, so what is esterification reaction? When alcohols reacts with carboxylic acid in presence of concentrated acid to give esters, that is called as esterification reaction. Now any example you can write down? Sorry. So for example, you can just take any alcohol, okay, and take one ester. So okay, so I have taken here methanol, okay, and ethanoic acid. Okay, so now you should remember here what actually which bonds are broken. Okay, so from alcohol this HOH bond is broken. Okay, okay, 1 second. Here I have to draw OH, right? Okay, and in case of acid, this OH bond is broken. Okay, so you need to show like this. Okay, please take care of this. If you broke in different way, it will be wrong. Okay, this is how the bond breaks, and there is a removal of water in presence of H plus. So we get, so this should be you have to write H plus, that is a concentrated acidic medium, and here there is loss of water. So this gives you what? Ester. So we will get CH3. Okay, then this part O is there. Okay, then this is lost, and then you have CO and CH3, which is an ester. Clear? Then next question. What is Lucas reagent? How it distinguishes primary, secondary and tertiary alcohol? So just now we have already discussed Lucas reagent is the mixture of ZnCl2 and concentrated HCl. Okay, so ZnCl2 and concentrated HCl, if it is there, that is called as Lucas reagent. Next, how will it differentiate? So tertiary reacts immediately, right, with turbidity. Secondary reacts after 5 minutes, right, and primary does not react, right? This is what you need to write in sentence. Okay, next, what happens when phenol reacts with zinc dust? Write the reaction. So when phenol reacts with zinc dust, what is formed? Benzene is formed, right? So when phenol reacts with zinc dust, benzene is formed. Okay, now if you want to write the reaction, so phenol with zinc dust will give you benzene plus zinc oxide. Okay, next, explain Coles reaction with an example. So again, Coles reaction is what? When you have in Coles reaction, sodium phenoxide on heating with CO2 at 433 Kelvin and 6 atm followed by acidification gives salicylic acid. So here you may not mention this one. Okay, this is not mandatory. You can write down in Coles reaction, sodium phenoxide reacts with carbon dioxide to give salicylic acid. Okay, so how is that reaction happens? So if you see, first we have OH. If you take NaOH, we get sodium phenoxide here, right? You may not show this one also. Then if you take carbon dioxide, we get OH COO minus, and then you may treat it with H plus to get OH and COOH. Okay, so you can see the reaction here. First you can treat it with OH NaOH, you get O minus Na plus, then you get CO2 and H plus to get OH and COOH, salicylic acid. Okay. Next question, identify the products when primary and secondary alcohols are passed over heated copper. So first you can write down primary alcohols will give you aldehydes. Okay, give an example for this one, like you have CH3, CH2OH, treat it with copper at 573 Kelvin, you will get CH3COH. Okay, next secondary will give you ketones, right? So if you have CH3, CHOH, CH3 with copper at 573, this will give you ketone. Clear? So one example and what exactly it will form. Okay, next, how phenol is prepared from aniline? Write the equation. So when aniline is treated with HNO2, or you can write nitrous acid to give you benzene disonium chloride, and then if you warm this benzene disonium chloride with water, you will get aniline. Okay, so then you will get phenol, and then you need to write the equation. So you can see the definition. Aniline reacts with HNO2, again this temperature is not required, to give benzene disonium chloride, which on warming with water gives you phenol. Okay, so the reaction you can see, you have aniline, here you have taken NH2, next NaNO2 plus HCl, that is the formation of benzene disonium chloride. Then if you warm with water, this OH will replace this N2 gas and N2, and will get N2 gas. So this is the final product, that is phenol. Clear? Next, how phenol reacts with concentrated nitric acid? Write the equation. So if you remember, phenols are highly activating group. So if you react with concentrated nitric acid, all the three positions, that is ortho, para, and like all the 2 ortho and 1 para positions are replaced with nitro groups, right? So as a result of which a picric acid, that product is called as picric acid, is formed. So how we will write the answer? When phenol reacts with concentrated nitric acid, very simply we will write like this: when phenol, okay, reacts with concentrated nitric acid 2,4,6 trinitro phenol, in bracket you can mention picric acid is formed. Okay, then you can write the reaction here. OH is present with concentrated HNO3 and concentrated sulfuric acid, we will get OH, and all the three positions are occupied with NO2 groups. Okay, so phenol reacts with concentrated HNO3 in presence of concentrated sulfuric acid to give 2,4,6 trinitrophenol called as picric acid. Then you can see the reaction here. Okay, simple one. So now we are done with the 2 marker questions, and now let us move towards the 5 marker questions. Okay, so in 5 marker questions I have analyzed like last 5 to 10 years of papers. Everywhere the 5 marker question is like 3 plus 2, and a 3 marker question is a mechanism. Okay, mechanism of acid catalyzed dehydration of alcohol to alkene, or mechanism of preparation of ethers. Okay, generally these 2 questions are in there almost all the questions. Okay, so please prepare these 2 mechanisms very thoroughly. Clear? Now first one, write the reaction involved in the mechanism of acid catalyzed dehydration of alcohols to alkenes. Okay, so first of all, if you remember, the first step is the protonation of alcohol, second step dehydration, third step is the formation of alkene. Okay, so I'll show you the mechanism here. So the first one, step number 1. Okay, step 1 is protonation of alcohols. Protonation, so let me write on this side. Okay, so step number 1 is protonation of alcohols. Okay, first step is protonation of alcohol. So you can take any example, CH3 CH2OH. In presence of H plus, what happens? We get CH3 CH2O plus H2, and this is a fast step. Okay, so this is protonation of alcohol. Now step 2, what? Step 2 is dehydration. Okay, so this protonated alcohol CH3 CH2O plus H2, right? This bond breaks and we get here CH3 CH2 plus. Next, step 3 is you can write down release of proton. Okay, so what happens here? We get CH3 like this, I'm writing, then CH2. Okay, and this plus is there. So what happens? This shifts here. Okay, and we get a double bond here, plus H plus. Okay, so this will give you alkene. Acid catalyzed. So you see in the starting there was an acid, and by the end of the reaction one acid is formed. Okay, that are the 3 steps that you must remember. This is the most repeated, very important question. Okay, next, explain the preparation of anisole by Williamson ether synthesis. Now anisole, if you know what is anisole, anisole is O and CH3, right? Just now we discussed anisole or any Williamson ether synthesis is what? Rx plus R dash ONA, right? So here what will be my answer? We need to react phenoxide ion with methyl halide, right? Rx has to be primary alkane, primary haloalkane. So explain, we need to explain it. So this is 3 marker and this is 2 marker. So one line will be explanation, one line will be the reaction in the second question. So I can write methyl chloride reacts with sodium phenoxide. Okay, sodium phenoxide to form anisole in presence of dry ether. Okay, now if I want to write the reaction, CH3Cl, okay, plus I will write phenoxide ion, sodium phenoxide, O minus Na plus. So this one will attack here, this bond will shift. So I will get here CH3 O benzene ring, that is anisole. Okay, clear? Next question, an alkane C3H6 reacts with H2O and one second. Okay, so okay, an alkene X C3H6 react with H2O H plus to give compound Y. Now compound Y further undergoes reaction with CrO3 H2SO4 to form compound Z. Write the IUPAC name of X, Y and Z. Okay, first of all we have C3H6 and reaction with H2O H plus to give compound Y. So so now if you see, this is a what? This is an oxidizing agent, right, to give you compound Z. Okay, so now if we see C3H6 is must be a propene group, right? Propene group, if you react it with H2O and H plus, so what will happen? Water will be added following Markovnikov's rule. So here OH and here CH3, right? So this is compound X and this is compound Y. Okay, next okay, now this one is treated with CrO3 in presence of H2SO4. Now this is a very good oxidizing agent, this is secondary alcohol, so we will get what? A ketone, right? So this is Z here. Okay, IUPAC name you need to write for X. X is propene. Okay, Y is what? Propane 2OL, you can just write down like this. Y will be propane 2OL, right? Next, you have this is propanol or propane 2-ONe. Okay. Now, which among the following compounds have the lowest and the highest pKa value? Lowest pKa value, so here one thing you should remember, lowest pKa value means pKa value is very lowest, means it should be highly acidic, and highest pKa value means low acidic. Right, we need to find the most acidic that will have lowest pKa value, because you know Ka and pKa are inversely proportional. If a compound is highly acidic, its Ka value will be maximum, but if a compound is less acidic, then if a compound is highly acidic, then its Ka value will be very high, but pKa value will be less. Similarly, if a compound is less acidic, its Ka value will be less, but pKa value will be very high. Okay, so now what are the compounds given? Para-nitrophenol, phenol, ethanol and orthocresol. So now if you see, phenols are always more acidic than alcohols, right? So here this one is like least acidic. Okay, cresol, orthocresol is what? OCH3. That is your orthocresol is, you have OH and CH3 here. Okay, now if you see, this one will be least acidic because it is a aliphatic alcohol. So least acidic means it will have the highest pKa value. So highest pKa value is for ethanol. Highest pKa value is for ethanol. Now if you come to lowest, lowest acidic, lowest pKa value means it should be highly acidic. Now if you see para-nitrophenol, it is an electron withdrawing group present. Electron withdrawing group will increase the acidity, whereas here there is an electron donating group and here there is no group, right? So this one, para-nitrophenol, is having a electron withdrawing group which increases the acidity. So therefore the most acidic compound will be para-nitrophenol and its pKa value will be lowest. So lowest will be para-nitrophenol. Clear? So I'll highlight these answers. Lowest acidic is para-nitrophenol and highest acidic is ethanol. Sorry, lowest pKa is para-nitrophenol, highest pKa ethanol. Okay. Next question. Give the mechanism involved in the acid catalyzed hydration of C2H4 to C2H5OH. Okay, so this is another mechanism, very important. See, there are two mechanisms. One is from alcohols to alkenes, another is from alkenes to alcohols, right? The previous one which we discussed was from alcohols to alkenes. Now this question is asking acid catalyzed hydration of C2H4 to C2H5OH. Okay, so I have given, okay, one second. So we'll discuss this mechanism now. So this is very simple. First what happens, you have taken, like I'll explain here also. Now see, protonation of alkene. So you have taken one alkene, okay, and you have taken acid catalyzed water. So acid catalyzed water means H plus and H2O is there. So this first step, what happens, this H plus and H2O combines to give you H3O plus, right? That is what I have is given here. Okay, now what happens, this one reacts with this H3O plus. Okay, so this one, this nucleo or this double bond attacks on this hydrogen and we get this one, right? So the first step is what? Protonation of alkene. Okay, because one H is added to this alkene, that is called protonation of alkene. Okay, next what happens, this carbocation is formed here, right? So after this one is there, we get like this, right? This H is there and we have C plus and this one. Now to this carbocation, water will attack. In the second step is the nucleophilic attack of water, right? So on this carbocation, this oxygen molecule will attack. Clear? This one is formed now. Okay, so what happens, see, you have like this, okay, 1 second, yeah, so yeah, you have like this, H is attached, now you have C plus and you have two bonds are attached. Now this H2O is there, its lone pair will attack on this one, okay, and this product is formed. After that, what should happen? One protonation, one hydrogen has to be removed. So that is deprotonation. So for the deprotonation, again we need water. It will abstract this H plus, this bond will shift here, and we will get the alcohol and H3O plus, which was present at the starting. Again that H3O plus will form. Clear? Next, okay, let me erase this part so that I can do part 2. Next question is, name the enzyme, okay, involved in the fermentation of glucose into ethanol and write its chemical reaction. So this is also there. This enzyme is called as your zymase. Okay, you can see here. So zymase reacts with glucose to give you ethanol and carbon dioxide. Okay, so glucose is converted to ethanol and carbon dioxide in the presence of the enzyme, that is zymase. Okay, here one more thing you should remember, from where we get this glucose. Okay, now see, we take like glucose can be produced from the hydrolysis of sucrose or starch. Okay, so you should remember zymase converts glucose to ethanol and carbon dioxide. Okay, now next question, explain the mechanism of dehydration of alcohols to give ether. So this is the third mechanism I told you. So the third mechanism will be dehydration of alcohols to give you ethers. Okay, so again I will discuss this mechanism in this way. So you can see, first step is what? Protonation of alcohol. Okay, so here there is one H. Okay, first step is, step number 1 is protonation of alcohol. This is the same step as that happens in the dehydration of alcohols to give you alkenes. Now after that, what happens here in this one? This is the protonated alcohol. Another molecule of alcohol attacks on this electrophilic carbon and this bond shifts here. Okay, so you can write down step number 2 is attack of alcohol. Okay, or attack by alcohol. Okay, okay, so now we get this one. Next one, third step is your deprotonation. Okay, so there will be a deprotonation and we get here the ether. Okay, and H plus. Clear? H plus, which is present as a catalyst in the starting, is reformed. Okay, 3 steps, 3 marks. Now how anisole reacts with bromine in ethanoic acid, give equation. So how anisole will react? So I'll write for this question number B. So anisole reacts with bromine. Anisole, oh, 1 second. Okay, anisole reacts with bromine and in ethanoic acid. So you can write CH3COH to give ortho and para substituted products. Right? Why? Because anisole is electron donating groups. Right? So if you want to write the reaction here, anisole is OCH3, and if you are treating it with bromine in presence of CH3COOH, so we will get one is ortho-bromo product, okay, and another one will be para substituted product. Clear? Okay, then last question, how is phenol prepared from benzene sulfonic acid? Next, write the equation. So you can just write down benzene reacts with oleum to give you benzene sulfonic acid. Okay, so benzene sulfonic acid on heating with sodium NaOH followed by acidification gives phenol. Okay, so you can see the reaction here. This is benzene. If you treat it with concentrated H2SO4, we get SO3H. Okay, that is your benzene sulfonic acid. Benzene sulfonic acid, if you heat on sodium hydroxide followed by acidification, sodium hydroxide followed by acidification will give you phenol. Okay, next, how anisole reacts with methyl chloride. So if you see, anisole reacts with methyl chloride, so again it will also give you ortho and para product, right? So anisole reacts, only you need to write the products here. Okay, methyl chloride, this is one product and this one is the para product. Okay. Next, what is the effect of electron donating group on acidity? Electron donating group decreases the acidity. Electron withdrawing group will increase the acidity. Okay. So the answer here will be decreases. Okay. So this is 2 mark, this is 2 mark, and this is 1 mark. Clear? Okay, so that's all the questions that I have taken in this session, but I'll be telling you now 3 important mechanisms I have analyzed last 5 to 10 years of question paper. In alcohols, phenols, ethers, 5 marker question, it is 3 plus 2, and the first 3 mark is always a mechanism. Okay, and what are these 3 mechanisms? First one is dehydration, okay, of alcohols to alkenes. Okay. Next, second one is dehydration of alcohols to ethers, and third one is acid catalyzed addition of water to alkenes. Okay. In these two many of you get confused, because one is from alcohols to alkenes, another is from alkenes to alcohols. So please read the question properly and then write down the mechanism here. Okay. So yes students, that's all. We have discussed a lot of questions using like MCQ, 2 marker, 5 markers, and I want all of you to read, learn these answers, learn these questions and practice it properly before going to the midterm examination. Okay, and I hope this video was helpful. This will definitely help you for your preparation, and if you have liked this video, then please do not forget to subscribe the channel. We'll be coming up with many more such contents. Okay, thank you for watching, and once again all the very best for your midterm preparation.